POTD. Today is 14th of October, and the problem says adjacent increasing subarray detection 1. So we are given an array nums of an integers and an integer k. We have to determine whether there exist two adjacent subarrays of length k such that both subarrays are strictly increasing. Specifically, check if there are two subarrays starting at indices a and b. Both subarrays are strictly increasing and they must be adjacent. Okay. Return true if it is possible to find two such subarrays and false otherwise. Okay. So so in order to do this problem, we need to check if there are two increasing subarrays, strictly increasing subarrays that are adjacent, and each of them must have a length of k. So basically this whole section will form a 2k, and yeah, then we have to check if it is possible or not. Okay, cool. So since the size is so small, we can just, you know, well, obviously it has to break on the first subarray, so the element that will start the second one will obviously be less than this one, because if it is not true, then so basically we just need those points where the order basically stops, right? So yeah, and then we can figure out if they are adjacent or not. Okay, so yeah, so how can we actually do this? Okay, so yeah, so they have to be adjacent, right? And all we care about is the previous value, which has to be greater than the current one, right? So okay, cool. So how I'll do this problem is, instead of just brute forcing my way, because brute force is the most obvious solution, we can easily do that. I will write both of them, but first I'm going to think about the optimal solution. Or it's not even optimal when the size is 100, but this is just a solution that I think should be good enough for us. So I'll maintain a count variable and a previous count variable, which I'll assign to 0, I guess. So what I'm going to do is I'm going to iterate through the entire array, and yeah, I can also have a num which is -1 or something. So I'm going to iterate through the entire array, and then I'm just going to maintain a strictly increasing order. So I'll just see that if nums of I is greater than num, then I'll just increment count, and if that is not true, then I'll assign num as -1 and count as 0, and count as 1, and number actually as the number that we have there. Okay, and yeah, this will be that. And every time I'm doing this, I'll also check one thing, that if and also I'll update the previous count here to count actually. So previous count will become the count, and then I'll just check that if our count double equals the previous count and count double equals k, then we can return a true, otherwise we can return a false. I don't know if this would work. Yeah, it didn't work. So we'll have to debug this a little bit, because let's just see. So Here the count value will be 1, here it will be 2, 3, 4 and 5. Okay, so I'll just print. Yeah, they can also be basically we just have to see if count is greater than equals k and previous count is also greater than equals k. Then we know for sure that the answer exists. Okay, cool, let's see. You can see. Okay, so it would be 5 and 0. Okay, 2 5. Oh yeah, we have to also update the num to nums of I. Yeah, so I don't know if it would work, but let's see. This is an O of n solution and it didn't work. Okay, it failed for this case, which is interesting. It shouldn't have. Yeah, I think so. Let's just see. But this is an O of n solution that I could think of. No, I wanted to use this. Why would it fail? When we are here in unknowns. Oh, okay. This is not big enough. That's only the reason. I think it should work now. Okay, it failed again. It is only minus 1000, so we can actually reduce it this way and actually see what is happening. I mean, it's all right. Okay. Oh yeah. Okay, I got it. Okay, so we can also have a single array that is increasing, right? So yeah. So okay, cool. Okay. All right. All right. All right. So it's like this. Okay. So basically we have count is greater than equals 2 times k, or previous count is greater than equals 2 times k, or we have this condition where they both form the standalone. Either one of them is like greater than 2 times k, then we can obviously be sure that we want to choose an array that is increasing, and we can just divide them there then and there. I think this should make this work. This was a nice edge case. Yeah, it worked. So this was the O of n solution. We can use it only runs in a one single for loop. I think this is the most optimal one. We can actually make the implementation better, but I think this is fine. And also I'll just write the brute force one. So in the brute force solution, I think it just basically what it does is it moves in sections of k. So for example, what let's just say we have a check function, and this check function has a start and an end. So basically this basically the length of r minus l plus 1 will be equals to 2 times k. So what we will do is we'll also pass the k here. So basically we will start our iteration from here, and then we'll go from plus k, and then we'll just increase our value, and then we'll see that basically we can also do this, and then we can just see that if we have to check the increasing order, so we'll just see that if nums of I is greater than nums of I minus 1, or basically we can just do this. If it is less than or equals to, then we can just return a false. And similarly we are going to check for this value here, so it would be L plus K plus 1, I is less than R, or maybe equal to R, I plus plus, and then we'll just check the same thing. And if none of these is returning a false, then we'll just return a true. So that would be, so basically this this takes the starting index, or we can just parameterize that. So, and the L is the starting index, then R is the ending index, K is the length of single subarray, and we have R minus L plus 1 equals to K. And what else we are left with? We are left with yeah, that's all. R minus L plus 1 equals 2 times K, which means that L to L plus K minus 1 is the first subarray, and L plus K to R is the second subarray. So that's all this function does. This is a brute force function, so we'll just do this for every index starting from, we'll do this like for I and I equals 0, I is less than n minus 2 times K plus 1. We will basically we will just check if check of I comma I plus 2 times K, then we'll just return a true. I think this should be something like the brute force one. So this is O of n squared, and this is O of n. So yeah, that's all.